Okay, today I'm going to talk about some variations of uh, relational methods. Uh, you may be familiar with some traditional ways of investigation of investigating the relationship of variables in a bivariate mode through correlation like Pearson correlation or in a multi regression through um, some predictor variables. But uh, as you know, in correlation and regression methods, we are just limited to study the direct effect of uh, independent variables on uh, dependent variables, something like this. And the relationships uh, are actually in a direct mode. So uh, the correlation coefficient um, methods for investigating bivariate variables has been actually deprecated uh, today in recent uh, article and research. Uh, Multiple regression, sometimes when the theory lets you investigate the direct relationships between the predictor variables and the dependent on criteria variables in very uh, uh, scare scarcely uh, situations uh, just theory may be fitted to this conceptual model, but in more than 95% of uh, occasions that you are going to delve into theory, uh, we are just uh, dealing with a theory that uh, looking forward to studying the indirect relationships of predictor variables. For example, in this case, uh, the direct relationship or the direct effect of x1 predictor may be insignificant, uh, but the indirect effect of x1 through the x2 predictor may be statistically significant. So yes, exactly. Yes, not covariation, it is mediation. When we talk about the indirect relationships, for example, in this case, uh, x2 variables mediate the relationship between the x1 predictor and the y criteria variable. So it is, in this case, this is mediation. And social and behavioral sciences, in most cases, you are dealing with a problem statements that the variables not necessarily have direct relationship with the dependent variables in your conceptual model. So you have to investigate the indirect relationship between the variables.
Especially when we're dealing with human beings with behavior issues, students.
Yes, of course, the behavior of teachers and students. And moreover, in the traditional methods of correlation and multiple regression methods, you are actually using observed variables. You are actually uh, ignoring the measurement error in the observed variable, and you may just investigate the reliability of the predictors, and when the minimum thresholds be met, you just use the variable in the multiple regression equations and do the predictions. However, there are certainly an amount of measurement error that actually is ignored in traditional methods of multiple regression. So there are ways that you can investigate the relationship between variables while you are controlling the measurement error. This is the case that we call it latent variable modeling. Actually, in the latent variable modeling, not only you can investigate the indirect relationships between the variables, but also you can uh, control the measurement error through the latent variables in the model. For example, if you are using SmartPLS that actually deal with models um, which start with questionnaire items, you can actually investigate the structural relationship between the latent variables while you are controlling for the measurement model that uh, showed here through the rectangles. So the advantage of the structure equation modeling here is that the measurement error, the reflective models like these four reflective measurement models like these four latent variables and some kind of formative latent variables like these four in the actually exogenous latent variables. The measurement are actually controlled here through these yellow rectangles here. So not only the direct relationships and the indirect relationships to one mediator or more than one mediators can be controlled in such structural equation models, but also you can control for the measurement errors here, and actually the quality of measurement in your model is actually controlled and checked, and some reliability and validity measures actually controlled in your model to make sure that your latent variables are actually some validated variables in your model, and your measurement is actually valid, because if uh, the variables actually latent variables in your model is not valid, so you cannot trust the structural relationships among these uh, latent variables. So in some uh, latent variable modeling methods, such as the SmartPLS modeling, that is suitable for uh, exploratory investigations among latent variables and hypothesis testing for uh, some latent variables in your models. That is suitable when you are in some preliminary stage of uh, actually in the preliminary stage of developing a theory, not testing a solid theory, because SmartPLS modeling has some advantages over other structure equation modeling methods, such as you can use low sample sizes. Low sample sizes, I mean, by less than 100, or less than 50 samples, you can do the analysis, the structure equation analysis, even with more populated models, including different latent variables, and you can use non-normal variables such as item questionnaires, like the model you see here, that this is a questionnaire that customer loyalty is actually predicted through some other latent variable, such as customer satisfaction, likability of the company, competence of the company, service quality, uh, and attractiveness, and the other uh, or performance of the uh, company, and other latent variables which can directly, like these three variables, and indirectly through these indigenous latent variables, can actually indirectly in different ways, like this, or even like this, can indirectly investigate the relationships of some indigenous latent variables with the indigenous, actually. These are indigenous latent variables. They are actually, this model actually deal with item questionnaire that questionnaire items that which are actually ordinal and non-normal variables, uh, indigenous variables means latent variables which pointed through some arrows in the model. I mean the circles here. The circles indicates the latent variables, and the circles which are pointed through other circles through these arrows are indigenous variables. You can see that these four latent variables are pointed through some arrows uh, from other latent variables in the model. But these circles are exogenous latent variables because they are not pointed by other variables in the model. So these are actually exogenous variables. This terminology is also the same for other kind of structure equation modeling like Ames, LISREL, and the way that um, um, the log-on package lover or do the structural equation analysis, and these are the other ways, or the other ways of the structural equation models are actually based on maximum likelihood estimation methods. But in SmartPLS, actually PLS is actually PLS stands for partial least squares. That is an estimation method of model parameter. So uh, uh, the way that we do the analysis in PLS has, as I said, have some advantage over other model SEM models, like using low sample sizes, employing non-normal variables in your models. Yes, normal distribution can be violated because smart PLS modeling is actually non-parametric methods of SEM modeling. The other methods that are based on the maximum likelihood, uh, like the way that we do the analysis in LISREL and Amos, or in R, some packets like Lavan in R, they are maximum likelihood based methods of estimation that they actually suppose the normality, multivariate normality assumption for the model. And in SEM-PLS modeling, we do not suppose the normality assumption, so we can uh, use ordinal, categorical, nominal, binary items. Actually, even nominal variables can be duly coded and then used in PLS model. And the other advantage of STEM modeling in the PLS way of estimation is actually the complex models with so many latent variables and testing uh, so many latent variables in a complex model can be uh, studied in SmartPLS. and it is not limited in this software to use so many complex models with so many latent variables, but in other actually covariance based or maximum likelihood methods of estimation, the number of latent variables are actually limited to be included in your conceptual model. Usually with more than 5 latent variables in a covariance-based model uh, may be so difficult for you to converge the model to get a fitted model. So this is the other advantage of the SEM modeling over other structural equation modeling methods. But this method of SEM modeling has a major disadvantage, and this is about the goodness of fit measures that yielded in this modeling is not trusted by statisticians because some weak goodness of fit indices are provided here for theory testing. Uh, Therefore, we cannot trust this way of modeling to test theory. And as you know, the theory testing is, is the backbone of the quantitative method that most often researchers actually dealing with testing theories, and the way that they see the research is to test theories, because the way of quantitative research is like that. There are theories provided by some scientists, some experienced scientists and researchers just suppose the theory, and they test the theory to actually generalize or refute the theory in a way that they can actually develop the theories in the field of study, like in education, teaching, and so on.
Because in order to maintain assumptions or estimates, also we cannot be sure that if the data is speaking for the model. I mean, there is much more in data that what we see as a model of the data.
Uh, Actually, the way that we look at theory testing in structural equation modeling are restricted in covariance-based or maximum likelihood-based of SEM modeling because the other way of SEM modeling provided you with some uh, absolute goodness of fit measures that uh, make you sure that the conceptual model and the theory that you are going to test is actually happening out of your mind. And this is the base of the quantitative research. So in actually uh, in software software like LISREL, uh, there are some path analysis examples, or even more sophisticated models like uh, path analysis or regression model through latent variables, you can, on these models, you can suppose any kind of exogenous or endogenous latent variables is that forecast high or it is maybe some educational or psychological variables, and you may suppose uh, any latent variable in this example is actually provided in the LISREL.
It is more simplified than the other way.
It is because you cannot make the latent variables uh, so complicated in LISREL. If you do that, you are getting yourself in a big trouble. You know? Because when you use numerous latent variables in your model, your conceptual model, yeah, you are actually you stay yourself in a big trouble, and the trouble is that you cannot fit the model. The goodness of fit the model that is provided in this modeling method is actually so extensive compared with the SmartPLS modeling. There are numerous goodness of fit measures, as you can see here in the section of the goodness of fit statistics. You have chi-square based goodness of fit measures that provide you with some absolute measures of goodness of fit, like the chi-square and the p-value that is provided here. A non-significant p-value, actually an amount of p-values more than 5%, provide you with a well-fitted model as an absolute measure of goodness of fit. This value tells you the conceptual model, whether the conceptual model is fitted or not. There are other measures of goodness of fit that also shows you absolute measures of goodness of fit, like NFI, NNFI, CFI, IFI, RFI, GFI. That should be more than 0.9. 0.9 actually measures greater than, greater, equal and greater than 0.9 shows you a fitted model or a fitted conceptual model, or a measure of AGFI more than 85.85 equal and greater than 85 shows you a fitted model, or one of the important ones that you see in other uh, ways of modeling, like even in IRT modeling and cognitive diagnostic modeling, the measure of RMSEA, which stands for root mean square error of approximation, provided. Uh, this is actually a measure that is based on the initial covariance matrix and the implied or reproduced covariance matrix based on the conceptual model. No, it's not squared. It's actually it's the root mean square error approximation is a measure that is based on the difference or residual matrix between two matrices, the row matrix, covariance matrix of the other variables, and an implied matrix that is reproduced through the model parameters after you fitted the model. So if these two matrices actually have the same elements, so the residual is approaching to 0. So all of these indices are based on these two matrices that is calculated for investigating of the goodness of fit of the model. We have also some relative measures of goodness of fit, like AIC and the different variations of the AIC, as you can see here. And the lower, these are for model comparisons. If you actually have several models, because you may have so many models that fit to your data, so you are going to choose the optimum model. The optimum model is the model that has the lower AIC. So these relative goodness of fit measures are actually here. These are the relative goodness of fit measures, and the other that I told you are the absolute goodness of actually the goodness of fit measures. And the way that covariance based or maximum likelihood based SEM modeling investigate theory is more conservative, and the measures that provide you are very exact. So actually you can trust the model, the goodness of it measures that is kind of software yields you. You can trust it that the model is actually occurring in reality of your classes, in your educational setting, and so on. This is not just happening in your mind or based on your qualitative judgment. Okay?
I have a question regarding ALC. You mentioned that whenever the lower the ALC, means that it has a better goodness of fit. Meaning if you imagine ample of arrows in the model, the one with the lower ALC means that this arrow is in the best position regarding with other arrows. This is what I got.
No. Model comparison are about fitting different models. For example, let me show you in this kind of modeling that you this is also through the path analysis that showed here. You may have a model like this. Let me delete this arrow. Let's suppose that just let me just do this again, and let me delete this arrow here. Okay, let me delete this arrow and run this model. The model actually does not converge because of deleting that arrow, and as you can see, even in the, let me see the goodness of fit. The goodness of fit of the model is provided here. As you can see, the absolute measures are actually confounded, decreased, significantly decreased, because we just deleted a significant relationship from the model, and the measures of AIC and the variation, if you just compare these measures with the AIC measures of the previous model, you can see that the AIC is actually increased. So both of the absolute and the relative measures are affected when you fit a difference model. When I talk about model comparison, this is about the way that the model is actually conceptualized. So if I conceptualize the model in a different way, you can see different measures. Because this is a multivariate analysis, when you add or delete a variable, the whole model is affected. The goodness of fit of the model is significantly affected when you delete a significant relationship in your model, either in measurement model or in structural model. So that's about model comparison. You are actually doing the model comparison with different conceptualization. And in covariance-based or maximum likelihood-based SEM modeling, there are some modification indices provided in this software that helps you to fit the model. For example, if I delete this arrow and run the model and ask for modification indices, you can see that there are some arrows recommended to be imposed to the model, or some covariance bars recommended to be freed for getting to a fitted model. In this case, actually there are some arrows, and the more logical with the more significant measure for changing the goodness of fit in a good mode is this arrow. So if we impose this through the recommendation of the software, we reach a fitted model. So if I back to the estimates and put this arrow on the model like this and run the model, this is actually like this. If you just you get to a model that is actually fitted to the model. I just make some changes to this model. I think this is maybe like this, and if I'm not wrong, have another path like before, isn't it? And this is the fitted model. So when you actually have some competing models in structural equation modeling, even in some PLS modeling or in covariance-based SEM modeling, you are going to fit the best model. In SEM PLS modeling, there are also some model fit measures like NFI or SRMR that NFIs more than in a liberal mode 0.85 and SRMR about 0, These are actually supposed to be good model as an absolute measure. But as I said, these goodness of fit measures are not so precise and well trusted. But for model comparison, uh, it may be useful. For example, uh, the DJ measure is a relative measure for goodness of fit. The measures approach to zero or close to zero yield you. Actually, the not close to zero. The DG of the models that are lower indicates that the model is better fitted to the other competing models. So the relative goodness of fit modeling comparison helps you, even in SmartPLS modeling, to find a better fitted model. Maybe the absolute goodness of fit of the model is not actually accepted. The whole model may be actually may not be fitted to the your data, but at least you can compare different models and choose the model that uh, has lower DG, and this relative goodness of fit measures helps you to develop a conceptual model or a theory in some preliminary stages. So these different kinds of modeling, the structural cohesion modeling, helps you uh, for developing a model or hypothesis testing, for predicting some direct and indirect relationships in a model, and at last it therefore uh, if your aim is to test a theory, the LISREL method is suitable for your purpose. And as I said, if your objective is to develop some hypotheses or to or you are going to develop a preliminary theory, the PLS is a good methodology for uh, for reaching to your research objectives. Do you have any question?
I wish we had more
Okay, good. You can find the videos on YouTube with and if you have any further question, you can ask me later on my classes on my channel.